Okay. Sigma bond is formed due to head-on overlap. Head-on overlap. Head-on overlap. This is the bond which will be formed first. ठीक है, ड्यू टू हेड ऑन और लीनियर ओवरलैप, ये सबसे पहले बनेगा. ठीक है जी. और पाई बॉन्ड क्या होगा? पाई बॉन्ड इज फॉर्म ड्यू टू पैरेलल ओवरलैप ऑफ ऑर्बिटल्स. ड्यू टू पैरेलल ओवरलैप ऑफ ऑर्बिटल्स. ओके, सो ये एक फर्क हो गया. दिस वाज द डिफरेंस. द अदर वन इज सिग्मा बॉन्ड इज स्ट्रॉन्गर. Sigma bond is stronger and pi bond is weaker. No, pi bond is weaker. अब let's suppose अगर मैं ये बात करूं, ये केमिकल है HC ट्रिपल बॉन्ड N, राइट? अब इसमें काउंट करने हमने how much sigma and how much pi. So this one is sigma and this one is sigma. So sigma bonds are कितने? 2 and the pi bonds are pi bonds are also 2, right, in this molecule. तो ये इसमें कुछ क्वेश्चन है, लाइक इसमें देखें. अच्छा, इसमें एक क्वेश्चन है, क्वेश्चन नंबर 28. हाउ मेनी शेयर्ड पेयर ऑफ इलेक्ट्रॉन आर देयर इन सिंगल, डबल एंड ट्रिपल कोवलेंट बॉन्ड? सो हाउ मेनी पेयर in single? 1 pair.
1.
And in double bond 2 pair of electrons are involved, and in triple bond 3 pair of. So draw dot and cross diagram to represent covalent bond in a molecule of carbon dioxide, right? I guess you can do this. We have also drawn yesterday. So draw dot and cross diagram to represent covalent bond in a molecule of ethene. Yeah. So drawing a covalent bond out of it. So you can write like this, because you have double bond between 2 carbon. So you can write like this. And then you have cross symbol for this carbon and dot symbol for this carbon. And now I can put some different symbol as star for hydrogen electron, any other symbol. Okay? So any doubt in it? Like showing this bond like this, because one bond mean 1 pair of electrons. One line, carbon, hydrogen, what it means? 1 pair of electrons. And this pair of electrons should not be with the similar sign. In dot and cross, it should have different signs. So next is you can draw this one as well, dot and cross diagram. Explain the difference between sigma bond and pi bond. What we have studied, sigma bond is formed by head-on overlap of orbitals. Head-on overlap of
orbitals.
What are the orbitals? That names is SPDF. Okay. So how the pi bond is formed? Due to the parallel overlap of orbitals. So which one is stronger?
The sigma bond.
Yeah, sigma bond is stronger. And pi bond is
weaker.
These are the two main differences, right? Okay, the next topic is about polar and non-polar covalent bond. So the concept of polar and non-polar covalent bond, like there is a concept of electronegativity. Electronegativity. So what is meant by electronegativity? Do you have any idea?
No, I haven't said it before.
Electronegativity, it is the ability of an atom to attract shared electron pair. It is the ability of an atom to attract the shared electron pair. Okay. For example, if you have a bond in between HCl, so it has the shared electron pair. What was expected? Expectation was that shared electron pair will be in the center between H and Cl. But in reality, it does not happen. The shape is like the shared electron pair is tilted toward the chlorine, is more toward the chlorine than toward the hydrogen. Right? Got the idea? It is not in the middle. It should be in the middle, which why we were expecting that it should be in the middle. But actually, where it is,
Towards
it is tilted toward one element, one atom. Why? Because chlorine is more electronegative. Chlorine is more electronegative, right? Than hydrogen. So that is why electron pair is tilted toward the chlorine, and hence it will get the charge of partial negative, and hydrogen will get the charge of partial positive, not the complete positive. I repeat, complete positive term is this one, Na plus and Cl minus. Complete positive means when the atom has lost the electron from its shell, from its orbit. And the negative mean when it has gained an extra electron. So partial mean just it indicates, partial positive mean it is less electronegative. So negative, partial negative like chlorine mean it is more electronegative. So who is the strongest electronegative element in the periodic table? That is fluorine, whose value is 4.0 according to the Pauling, who discovered this phenomenon. So what you have got about electronegativity? What is electronegativity? It is the ability or the power, to attract shared electron pair. Shared electron pair means the electron pair which is involved in the bonding. Shared electron pair is that pair in which the electrons are from two atoms. One electron is donated by one atom, one by sharing by the another atom. So that is the shared electron pair. Okay. There is another pair of electron which is not involved in the bonding. What is that pair called as? For example, if I am talking about chlorine. So chlorine has 7 electrons in the last shell, 2, 4, 6, and the 7th one. So what are these pairs called? This pair of electron and this pair of electron and this pair. So keep in mind, these pair of electrons are called as lone pair of electrons. Okay, got it? Okay. So now you have got the basis of polar and non-polar covalent bonding. So what are the bases of polar and non-polar covalent bonding? The bases are electronegativity concept, polar and non-polar. Okay. So polar covalent bond exists in the case when you have electronegativity difference between the bonded atoms. What I said? The polar covalent bond is a bond when the two bonded atoms would have different electronegativity. For example, for your convenience, H2, Cl2, N2, O2. All these atoms are the bond in these are non-polar. Why? Because think why they are non-polar covalent bond. Because in hydrogen it is HH, both have the same electronegativity because both are hydrogen. Okay. In other words, I can say the shared electron pair will remain exactly in the center. Because both have the same power of attraction for the shared electron pair, right?
Okay.
Got it?
Yeah.
Same is the case for chlorine. So in short, what you have learned, the bond of homoatomic, bond of homomolecules. Homo means same.
Yeah.
Is
Same,
non-polar covalent bond always, right?
Yeah. Yeah.
So what I told you about the bases, like HCl. In HCl, you have the shared electron pair tilted toward the chlorine, and chlorine has partial negative and hydrogen has partial positive. In other words, I can write this one. So this is polar covalent bond.
Yeah.
This is polar covalent bond.
Yeah.
So for polar covalent bond, one element should be more electronegative and one element, the other element or atom should be less electronegative. Then in those cases, the molecule have two poles. One is partial negative and one is partial positive. Such bonds are called polar covalent bond, and such molecules are called polar molecules. Got the point?
Yeah. Yeah.
Okay. So whose bond will be more polar? Obviously, I told you one element is the which has the high electronegativity in the world. That is HF. This bond is more polar than any other bond in the world because chlorine has the more electronegativity. Okay?
Yeah.
So what is the effect of polar covalent bonding? What is the effect of polar covalent bonding? So due to the polar covalent bond, molecules are polar, means they will be, the principle is like dissolve like. Polar are soluble in the polar, okay, and non-polar are soluble in non-polar. Got it?
Yeah.
Okay. For example, water. What about water? Water, H2O.
H2O. Yeah.
Okay. So water is also polar.
Polar, yeah.
Okay. If water is polar, it means water will dissolve polar compounds. For example, if you don't know, if I ask you why alcohol is soluble in water, and you have just listened to the two concepts, like dissolve like and water is polar, now you can conclude the answer, you can deduce the answer. I am again saying why alcohol is soluble in the water. So you might say if it is soluble in water, it means alcohol will be polar. I told you like dissolve like, polar dissolve polar.
Polar.
Okay, alcohol is soluble in the water. That means water is polar and alcohol is also polar. That is why they are soluble in each other.
Yeah.
Got it?
Okay. Yeah. Okay.
So, okay, if the bonds are polar, they would have strong van der Waals forces. Strong van der Waals forces. They might have, you may say that strong hydrogen bonding.
Yeah.
Okay. And as a result of, they should have high melting and boiling point. High melting point and boiling point in the polar bonds. Okay. Their bonds become stronger. Okay.
Yeah.
Got it?
Yeah.
So now you have characteristics of covalent substances. So what are, okay, in previous lessons, we have studied the characteristics of ionic substances. Do you remember? Solubility, electrical conductivity, crystallization process, and all that. So similarly, here he is mentioning a term, probably either you are familiar or not. This word means intermolecular forces. So inter, do you know the meaning of this? Okay, nobody. Let's break this word into the pieces. Word inter mean, beta. It means between. Okay? And wherever the word inter is used, I-N-T-E-R, it means between. Molecule. Molecular mean it is linked to molecule. So, force. It means force of attraction or repulsion between molecule. Force of attraction, you may say that between molecule is called what? intermolecular force. Okay?
Yeah.
Got the point?
Yeah.
Okay. So in covalent substances, intermolecular forces are weak. Mean attraction between the molecule is weak.
Weak, yeah.
Okay. Though in those covalent substances in which attraction is very weak, they are gases. In which it is a bit stronger, those are liquid. And in those covalent substances where intermolecular force is very strong, then that substances will be solid. Got it? In the weakest,
Yeah. Okay.
the weakest intermolecular force in the covalent substance exists in which state of matter? Gas.
Yeah.
Got any confusion, any doubt?
Yeah. No.
Yes.
No. Fine.
Why the gases have weakest intermolecular force, beta?
Because they don't have a
because their
strong
distances
attraction.
between the molecule is large.
Larger, yeah.
That they would have weak intermolecular force, right?
Yeah.
You know that it's a basic phenomena. The gas molecule exists like this thing. Got it? And the solids are like this. Got it?
Yeah.
Okay, this is blur. And let me check how the molecule HCl react with water to form. Oh yeah. They are soluble when they will form ions with water to conduct electricity. Like HCl is a covalent compound, but when it dissolves in water, it forms H positive and Cl negative. Okay, in the world, do remember the rule that things will be conductor of electricity in two conditions. Either they have free electron or they have free ions. In these two cases, anything will be the conductor. Otherwise, it will be insulator. I repeat, if anything, like if someone asks you why iron is the conductor of electricity, you can say that it has free electron. But when it is asking for any compound, and if it is telling you solution of HCl is conductor of electricity, explain why. So if it is the compound, then definitely it would have free ions. Because if the examiner is telling you, beta, that HCl solution is the conductor of electricity, so in the solution you would have ions. But if it is a metal, like iron is a metal, gold is a metal, and gold metal is the conductor, if it examiner is telling you the gold metal is a conductor in the question and asking you why it is conductor, you can say that it has free electron or delocalized electron. Free electron, or the other word is delocalized electron. Okay?
Yeah.
Okay. Most covalent substances do not dissolve in water. So here the rule is simple. All the polar covalent compounds are soluble in water and non-polar covalent compounds are insoluble in water. So I told you the example of hydrogen, nitrogen, oxygen. Now my question is, why these gases are not soluble in water? Because they are non-polar.
Because they're non-polar.
Non-polar, and water is? And water is?
It's polar.
Polar. Why HCl is soluble in water?
Because
HCl is polar. We just realized that it has the electronegativity difference. Got it? I guess you could not patch up these questions. I am asking you, the simple rule is like dissolve like. Okay? Like dissolve like. So polar will be soluble in water. Polar will be soluble in polar substances. Non-polar soluble in non-polar. Oil is soluble in oil. Coconut oil is soluble in canola oil. Canola oil is soluble in other oils. Petrol is soluble in diesel, because all these are non-polar things. Okay?
Yeah. Okay.
But HCl is soluble in water. Why? HCl is not soluble in petrol. Because HCl is polar and water is polar.
Polar, yeah.
Got the concept?
Yeah.
Okay, good. These are experiments, so I am leaving these beta. Oh, here is the concept of electronegativity. So electronegativity, we have read it. Electronegativity is the attraction of atom for the shared pair of electron in a covalent bond, right? So the factor responsible for electronegativity, 1, 2, 3. The nuclear charge, okay. Who has the more electronegativity in the world? Which element? For which element I have told you?
Fluorine.
Fluorine. And where does fluorine exist in the periodic table?
Yeah.
Let me go to the periodic table. Here it is fluorine. So it means
Right, on the right side.
Yeah, fluorine is maximum. It means the electronegativity will increase from left to right in periodic table. Got it? Electronegativity will increase from left to right in a periodic table because fluorine is maximum, which is on the right side. Okay? Got the point, beta?
Yeah.
And what about top to bottom? What about top to bottom? Fluorine is highest. So top to bottom, it will decrease. When fluorine has more, chlorine has less than fluorine, and bromine has less than chlorine, and iodine has less than bromine. Okay?
Yeah.
Sure? Any doubt, beta? Okay. So this was the concept of electronegativity, which is highest in the fluorine. It is basically the property of non-metal, not the metals. So fluorine is a non-metal, a good non-metal that has the highest value, and it exists mostly in the covalent bonding predominantly. And due to the electronegativity factor, the concept of polar bond arises. Okay? This is what he is explaining. The electronegativity increases across a period. Electronegativity decreases down the group. So these trends you can read. Okay, predicting the nature of bond. Predicting the nature of bond. So what is meant by the nature of bond? If you have a bond like HCl, HF, and you are subtracting the values of electronegativity. Look at this. Here you have the values of electronegativity. Let's see, value of H is, look at this, electronegativity value of H is 2.1. And what is the value of Cl? Look at this, 3.0. H is 2.1 and F is 4.0. Got it? Okay, let's take the difference. 3 minus 2.1, it would be 1.9. Okay? And here, no, sorry, 0.9.
Yeah.
And here you would have 4 minus 2.1, that is 1.9. This is called electronegativity difference. 0.9 for HCl and 1.9 for HF.
Yeah.
Okay? Now, what is the point? How you can predict the nature? Higher the difference, higher the electronegativity difference, higher the electronegativity difference, stronger, more polar bond, and more ionic character. And more ionic character. It means ionic character is more in HF bond than in HCl bond. This is what I mean. You got the 3 points? If you have different kind of bonds, you will be provided with the data like this. Here the value is given on the bottom. Okay? And here you see, what about the fluorine? It is 4.0. Okay?
4,
Right. So if you have higher difference of electronegativity, what conclusion you can make? The bond is going to be stronger? bond is going to be more polar.
Stronger. Yeah.
And bond should be
Yeah.
would have more ionic character. Okay.
Ionic. Yeah.
Do you understand the
Yeah.
ionic character?
Yeah.
Look, mean ionic, not the ionic bond, mean ionic character.
It's.
Okay.
Yeah.
Here he is doing the calculation and explaining it. You can read these later on.
Yeah.
Okay. Here he is giving you a term. If the difference is more than 1.7, it means the bond is ionic. If the difference is, look at this. If the difference, I am talking about the delta value, delta of difference of electronegativity.
Yeah.
If it is less than 1.7,
Yeah.
the bond is covalent. If it is more than 1.7, the bond is ionic. Okay, this is what they are concluding it.
Yeah.
Got the point?
Okay.
Look at this. Here its answer is 0.4 for CH4. And he says the bonding in CH4 is weakly covalent. Okay, let's suppose in HCl, if you have the delta value 0.4 and delta value of electronegativity is 1.2 for a compound A and compound B, which compound is more polar? Compound A has electronegativity difference 0.4. Compound B has electronegativity difference 1.2. Which bond is more polar? With the higher value, with the higher difference value.
The B.
Okay, the B, right?
The B. Yeah.
Okay.
Yeah.
So here are the definition, electronegativity, trends, we read it and all that. Prediction about polar and non-polar. You can practice these, you can solve these, and you can send me whenever you would have a free time from college.
Yeah.
Okay. So here you have a lot of questions to do.